All right, this is the first question packet provided to you that focuses on FRQ 4 questions from the AP Pre-Calculus exam. So we are supposed to rewrite the function g of x as a single logarithm base 3 without any negative exponents. Let's get started. So the first thing I'm going to do is I'm going to look at the coefficients out front, and when I condense this, they're going to turn into exponents. So log base 3 of x squared plus log base 3 of x to the fourth. Next, as we condense this, addition turns into multiplication, and if there was subtraction, it turns into division. Log base 3 of x squared times x to the fourth. And now we're going to jump to our exponent properties. When we have the exact same base, we keep the base and we add the exponents. Make sure not to circle your result, it will negate the work you did. Let's go on to the next part. We're going to rewrite the expression in which secant appears once and no other trig functions are involved. Right. So for h of x, I'm going to start by rewriting tangent. I know tangent is equivalent to sine over cosine. I also know that cosecant is equivalent to the 1 over the sine. And now instead of writing this vertically, I'm going to write it horizontally. So divided by cosine, which is cosine over 1. We can see that the sines, oftentimes I hear kids say canceling out. Remember, it's just going to reduce to 1. So I have 1 over the cosine of x. Division turns to multiplying, and then I take the reciprocal of the second fraction. Now as I multiply straight across, I end up with 1 over cosine squared of x. Remember, we're supposed to rewrite this expression in which only secant occurs. Now I know that cosine and secant are reciprocals of one another, so I can rewrite this equivalent form as secant squared x. Again, make sure not to circle your result. We want the AP reader to see our work and understand. Okay, we're moving on right now to part B of this first practice question. So in part B, we want to solve when j of x equals 4. So I'm going to write down all my steps here. So j of x equals 4. Now I'm going to replace j of x with the value of 4. So 4 equals log base 2 of x plus log base 2 of x plus 6. I just want to go off to the side and give you just a quick refresher about logarithms. When we look at logarithms, we have the base, the answer in back, and exponent behind. Sorry, occasionally I have to stop here and check some answers. These values must always be always greater than 0. So just keep that in mind. After we check our answers, we do need to make sure that it does fall within the domain of this function. Okay, let's start by compressing this. So as we compress it, we have the same log base. Again, as we spoke about in part A, addition will turn into multiplying. So I have x times x plus 6. I'm going to go ahead and I'm actually going to distribute this. So I get x squared plus 6x. Now let's write this in exponential form. So think over here. When we write this in exponential form, let's just say this was a, b, and c. Just giving that 3 variables. When you change this to exponential form, the base remains the same. We're going to raise it to the value that's across the equal sign and set it equal to the value that's directly behind the base of the log. So in doing that, we have 2, and even though the log in this particular equation is on the left, it's on the right here. We're going to raise it to the value across the equal sign and set it equal to x squared plus 6x. Okay, well I know that 2 to the fourth is 16, and now I'm going to move 16 to the opposite side. Remember that on this test, we are not going to skip any steps, so we're going to show all of our work as we move throughout this. Is this factorable? Do I know 2 things that multiply to give me negative 16 and combine to give me a positive 6? 8 and 2, that could be different signs, positive 8 and negative 2. So I have x plus 8 and I have x minus 2. Now if this is true, either one of these quantities equals 0 or possibly both. Remember, do not skip any work. Show all of your steps. So I believe one potential answer is x equals negative 8, and it's so easy for me to want to circle those results. Again, we're going to keep them here. If we circle them, it negates all of this work that I've done. Now I need to go back here. I need to go to this original and see if this works. I can see if I plug in a negative 8, I'm in trouble. Hold on, I got to check something. All right, thank you for watching this, for your patience as I go back and check. Right now, I'm going to check for extraneous solutions. What that means is I did all of the work. It looks beautiful. but is it really part of the domain? So when I take and I check this -8 with this original problem, remember this value has to be greater than 0. So this is an extraneous solution. So I'm actually going to write that out. It's an extraneous solution. I do not want to include it. But now I can put a 2 in. A 2 provides a value that is greater than 0. And a 2 plus 6 provides a value that's greater than 0. So my only answer is x equals 2. Let's take a look at the second part of B. So now I have k of x equals 7. I'm going to replace k of x with 7. So 7 equals 6 plus 2 sine squared x. Again, I'm going to have to pause periodically to check students' answers. Alright, so the very first thing I'm going to do here is I'm going to subtract 6 to both sides, and I end up with 1 equals 2 sine squared x. I'm going to divide both by 2, and I have 1/2 equals the sine squared x. Okay, so in order to isolate the sign, I'm going to take the square root. Now, as a reminder, I'm going to have 2 answers, plus or minus. So I want to know 2 things. I want to know when is the square root equal to positive 1/2, and I also want to know when is the square root equal to negative. Okay, so this looks a little funky. So we're going to take the square root of 1 over the square root of 2. And over here, the square root of 1 over the square root of 2. Now I know the square root of 1 is simply 1. But by the way, we can't leave this in this form. Remember, we can't have a square root on the bottom. So we're going to take the square root times the square root of 2. And I'm left with 1 square root of 2 over the square root of 4. And I know the square root of 4 is simply 2. So it looks like this. If you're free to put a 1 in front, you don't have to. And the same thing here will occur. So we can see we start at the same thing. The only difference is we have a negative. So this is going to be negative square root of 2 over 2 equals the sine of x. Okay, what is next? So the next thing we want to do is we want to ask ourselves, where on the unit circle can I find positive square root of 2 over 2 as a sign? And that's going to occur, positive is right here and right here. So we have at pi over 4 and at 3 pi over 4. And where can I find a negative? At 5 pi over 4 and also at 7 pi over 4. Now let's go back and let's see really quickly. Let's go back and let's check really quickly. What does it say about the restrictions? Is there any restriction here? Okay, so it says find all values, let's see, find all values of x in the interval from 0 to pi. So I only want my answers from 0 to pi. So when I look at from 0 to pi, that means from here to here. So this falls into that range, this falls into that range, these do not. So my only answers would be x equals pi over 4 and x equals 3 pi over 4. But this is a great learning opportunity. I do want to stop for a second. If there was no restriction into where I could find values of x, so if it did not limit where I could find the x values, I just want to take this time to practice. How could I write this? I would write x equals pi over 4 plus 2 pi n, and x equals 3 pi over 4 plus 2 pi n. And up here would be x equals 5 pi over 4 plus 2 pi n, and x equals 7 pi over 4 plus 2 pi n. Again, this is if there was not this restriction of where I want to find the values of x. And then I'd have to say that n is any integer. So this would allow you, if there was 0 restrictions on how many times I go around, we know this is one solution, and every time I go around one revolution, which is 2 pi, and land at the spot, it would be another solution. The same as here. We know this is one solution, and every time I go around and land at this position, it would be another solution. The same for the other two. I want to reiterate, this is only if there was no restriction. I just use it as a learning opportunity. But for this problem, we have pi over 4 and 3 pi over 4. All right, let's go on to this last one. So for this very last one, I want to find all input values of the function m of x that give me an output value. Well, remember that we got to think about what is this. So a couple things to think about. I know that arc cosine provides me solutions in quadrant 1 and quadrant 2, so from 0 to pi, right? So I want to first figure out where do I find a positive cosine value that's the square root of 3 over 2. So 1, 2, 3, so 3 over 2 is here, and 3 over 2 is here. So I can find a positive cosine value at pi over 6 and 11 pi over 6. But it also has to fall in this range from 0 to pi, making this the correct result of the arc sine of the square root of 3 over 2. So I'm going to take and set this equation equal to, so pi over 6 is equal to negative 2/3 inverse sine of 5 square root of 2x. I'm going to start by multiplying by the reciprocal. So negative 3/2 and negative 3/2. Alright, so we can see that these reduce down, so they're simplifying to 1. And you may want to write this as arc sine. Feel free to write this as arc sine or leave it as inverse, whatever you prefer to write. Over here I have negative pi, 3 pi over 12. Well, I know that reduces down to negative pi over 4. Now, why I'm leaving a little bit of room is that, remember opposite of adding and subtracting, opposite of multiplying is dividing, opposite of square is square root, right? Well, if I want to remove the arc sine to the left and to the right, I'm simply going to do the sine. So on the right-hand side, I'm left with 5 square root of 2x. Here, I'm asking myself, what is the sign when I drop down to this position? So if I drop down 45 degrees, which is equivalent to 1 pi over 4, a negative 1 pi over 4, I have square root of 2 over 2 and negative square root of 2 over 2. And I'm looking for the sign. So I have negative square root of 2 over 2 equals 5 square root of 2x. Alright, so I'm going to multiply the left and the right by 1 over 5 square roots of 2. 1 over 5 square roots of 2. So on the right-hand side, you may think of these as canceling out. Remember, they reduce down to 1, and I have x equals, the same thing happens, square root of 2 and square root of 2 are going to reduce down to 1, and I have negative times 1 is negative 1 over 5 times 2 is 10. Don't circle your final result. It negates all the work we did to get to this point.